everybody. It is so cool to be really live back on a trade show. So where are we right now, Felix?
We are in Hannover. Hannover is obviously known for the German with the least accent, so very, very accurate German, which the people are speaking here. And apart from that, Hannover is also known for the Hannover Messe, one of the biggest trade shows in the world.
I think it is the biggest industrial trade show of the world.
The biggest
Yes.
industrial
One
trade
and only
show of the
biggest,
world.
yes.
Yeah, you see
Yes.
even more to know about Hannover. And we are also live on the Beckhoff homepage and live on LinkedIn, for example, for Beckhoff Live and Interactive. Because last year on the Nuremberg Fair, which
Right.
did not happen, we invented Beckhoff Live and Interactive to present everybody out there in the world who is interested the technology highlights which we have invented and which we want to distribute into the world in 3 times 30 minutes. This time on the Hannover Fair we have also prepared the same program with 4 times 30 minutes on the latest technological news from the automation market.
Yes, and you can get in touch with us, use the communication channels, or write an email to meet at Beckhoff, talk to the Beckhoff salespeople globally, whatever. But there's today something really worse. If you seriously look to my smartphone here, it's now 8:22 on Sunday. So it's not really live, and there's a good reason for this, because just in half an hour from now, because you are watching on Monday, right? So in half an hour from now, the German Chancellor and the Portuguese Prime Minister is going to see us here, and that's why everything is already built up. And we do the recording just this time on Sunday, but also live, correct?
Yes, we are doing it live, and you can also ask questions tomorrow, which we will answer live. So you can contact me at beckhoff.com or write in the chat, and then you will get a live answer to it.
Oh, it's like time shift. This is so cool. So let's start time shifting, and we start with technology. And I will take you out there to our MX system. And for those who don't know me, when I started to work a couple of years ago, I actually started as an electrician. So I made an apprenticeship as an electrician, and I started to build cabinets, electrical cabinets. And now in this trade show, we present our MX system, and the idea is to replace the cabinet. So Daniel, you are going to replace my cabinet?
Yes, I will replace your cabinet.
Oh, this is so
yes,
lovely.
But of course, I was also an apprenticeship as an electrician, so 30 years ago, and so I know it's time to send the cabinet to retirement.
Okay, time to say goodbye. Now, let's take a look. What is MX basically all about? What are the key characteristics?
The key characteristic is that we have a fully IP67 degree waterproofed system that has a base plate. On the base plate, there's electronics inside, are mounted modules, function modules, what we call it. And this the whole system is then waterproofed, as I mentioned, and it is one unit, and this unit is able to replace the cabinet.
Okay, so it's like Lego for grown-up, to say it this way, but showing it on a print is easy. I think we have also live samples. So what live samples do we have?
Yeah, we have a lot of live samples, as you see here. Yes, and here we start with a live sample. That is our base plate. Here's this is the standardization of interfaces. That is one of the secrets behind the MX system. We have 2 interfaces. We have one for data and for 24-volt power supply, and we have one interface connector defined for 400-volt and 600-volt DC. So these 2 interfaces. With these, you are able to connect every module to the base plate, and the base plate is it is the wiring of the cabinet. What you done in your apprenticeship is the wiring, and that is now here part of the base plate.
So, but then if I have the base plate with EtherCAT communication and power, I just need to plug in parts, and that's it?
Just need plug in. If you want, you can plug a module.
So
you want.
I think if you take a look to the downside, we can see the connectors, what you talked about, communication and power. So I should really try it?
Yes, you can try it.
Okay. I hope I can do it, because we will ask our Chancellor tomorrow the same thing, or actually in half an hour. That's it?
That's it. Yeah, you're ready to connect and wiring a 2-time axis servo module.
Wow. I think then, if we have the base plate, the clue is the portfolio. What do we have?
Yeah, we have, what do you need? A PC. It starts with a PC. You need a master for our EtherCAT, for TwinCAT. You need a PC. We have PCs in different sizes and power, so that is a PC. Then we have coupler modules. That is a little bit similar to the PC, but this is, for example, for your panel PC with EtherCAT, or example also for Profinet, for a master control from someone else, with Profinet master or an Ethernet IP master also.
Okay, and this looks like our bus boxes. So this
It
is
looks
IO.
like our bus boxes. It is similar to our bus boxes, our I/O portfolio for the MX system. It is the same as we have before in EL and in bus boxes. All the most things we have from easy 8x8 input digital inputs up to the current motion technology. We have
Okay.
all included this.
Faceplate, PC, IO. I see motion.
You see motion, these are drives. These are our servo drives. It's similar to the AX8000 family. We have the DC link system, and new in the MX system are frequency converters. So we have now frequency converters from Beckhoff as part of the MX family.
So basically everything we know and we can do already for centuries in a new form factor, but there's one new module.
Yes, there is.
I
this
think
one.
your personal highlight, is it?
My personal highlight is our main switch module, how we call it. Here it's for the in-feeding power, so for 400 volts, 480 volt, 3 phases coming in there. And then we have the main switch, we have here the fuses inside, we have a line filter inside, we have power measurement inside, we have a 24 volt power supply inside this module. And this is normally on the cabinet, if you remember, this must be a space from 800 up to 800 by 800 millimeters. And now we have here to 110 millimeters and 240 millimeters.
Oh, this is so cool. And there's another highlight for this, and this is it can all be done and controlled and programmed with TwinCAT. And that's a good switch over to Felix to the TwinCAT department.
Yes, sometimes we try to set a trend by ourselves. The MX system is a wonderful example for the cabinetless machine. Sometimes trends are global, and we want to help all of you actually utilizing these trends. And for this, Fabian is with me, who is an expert for artificial intelligence. So Fabian, can you tell me what is the machine building industry actually doing with artificial intelligence?
Well, so some of our customers are actually building real applications and bringing those applications into their existing machines or also into new machines. So for instance, one of our customers is doing an anomaly detection for quality inspection on a high volume productive machine, and which is very interesting application. So you are able to detect an anomaly of the quality of the product, and you're able to just throw out this product that is not delivered to the customer. Very interesting, and also we also use this technology on our own to enhance our products, like we do with the anti-cogging application for our linear motors.
So all sorts of use cases, inspection, improvement of motion products, and I've learned about machines that everything needs to happen deterministic. So every 250 microseconds, every millisecond, there needs to be an action. How can we bring this together? So the machine learning world, neural networks, and the deterministic requirements of a machine.
Well, basically saying we have smart engineers in our headquarters, and they just sat down and wrote the architecture of neural networks, also of classical machine learning algorithms like support vector machines, k-means, random forest, blank as TC-COM objects, so standard objects in our TwinCAT world, and they can run on standard IPC hardware in hard real time. And for those customers who say, hey, the CPU is not enough for us, I need a GPU for acceleration of algorithms. This is also that we show here in Hannover, that we are able to utilize also the power of GPUs and accelerate big CNNs, for instance.
Okay, I think that's very popular in visual inspection and in picture analytics. And for this, I think Michael is our expert who can talk a little bit about the new things in the TwinCAT Vision portfolio. So thanks, Fabian, and welcome, Michael. So Michael, can you actually tell us what's happening there in the TwinCAT Vision portfolio?
Yeah, we plan the next release for the beginning of the third quarter, which contains many optimizations, usability improvements, and a lot of new image processing functions. But furthermore, it provides the base version for some new features. So one is the programming in C++, where we provide a header file that you can integrate and access all of our vision library functions. So you don't need a PLC program anymore. You can program everything in C++. And the next function that we will provide is an OCR function, means optical character recognition, where you can detect and recognize characters from an image. For example, you can read best before dates and check or validate them. So the first release will include just recognition of numbers, but later on we will update the possibility to detect all characters.
Okay, wonderful new features and possibilities on the engineering side, but how about the interaction with the vision components? Is there also something which you would like to talk about on that end?
Yeah, we actually try to, or we will release until the end of this week a new HMI control package. This mainly contains one color control for setting and displaying colors and an image watch control where you can do a lot of functionality what we have integrated. So for example, you can zoom in, scroll, draw some different shapes for region of interest, and yeah, many more features that we built in.
Okay, actually easier to use, more common if you are used to the actually up-to-date IT technology which we have at home. And I think this is also a very, very good keyword for our last TwinCAT expert of the day, Pascal. Thank you, Michael. Pascal, you are very much familiar with showing data, displaying data, and analyzing data. On the dashboard side of TwinCAT Analytics, what can you tell us about the news there?
Oh, yes. As you know, TwinCAT Analytics is providing this one-click dashboard, so it is a very easy way to generate from a TwinCAT Analytics configuration your own web-based dashboard based on our HMI, right? But of course, it is a static solution, right? For changes, you have to go back to the engineering world. But now here at the Hannover Fair, we show our interactive functions. Like you can see in this short video here, we have the option to change the size of the different controls. We can provide new positions for the controls. We can enable the controls, disable, and this really individual for each user credentials, right? And so we are much more flexible now.
Okay, so also there the trend, the interaction with TwinCAT becomes more natural to and more common to what you know from the classical IT technology which you use at home. If I have watched the data and if I've interacted with the data, is this actually the end of the whole data chain?
No, it is not the end of the data chain. So for sure we have the possibility to store the results from the analyzers, but we can send them also via different communication protocols. You know, TwinCAT is a very open platform, but an additional option now, and this is also what we present here, is our reporting functionality, right? With the reporting functionality, we can generate reports, so a collection of data in different views, so with charts, with tables and so on, from Scope View and also from TwinCAT Analytics. And then you have something like here, this PDF report, or you have an HTML page, or you have a JSON file. And finally, if you like, you can send this automatically via email. So something is happening in your machine or the test bench is finished, then we send automatically the PDF report from your controller.
So your machine controller is giving you all the information which you need to know about your machine. But
sure,
to make this happen, you actually need a machine controller, and that's why Roland is standing over there with Heiko talking about embedded PCs.
This is so cool. Pascal said it's not the end. Well, working with Beckhoff is never the end. We are always in between developments, new technologies, new products. There's always so much going on. And Heiko, there's also something going on in our embedded PC portfolio, and this is our CX56. What is this all about?
Yeah, so CX56 first showed virtually last year, but now here in reality. It's based on the AMD R series, so it's embedded series. It's comparable to Core IU from the Intel portfolio. So it's not a direct successor to Atom-based devices. It's more like a in-between filler. So we have now Atom-based devices, and we have CX56 with that AMD small Ryzen device, and then we have, of course, the high-end devices, CX2000 series. And so we can really put that in the middle there, and then we have a complete portfolio.
And I noticed that you also have a new module which goes in line with the Ethernet ports on the AMD, right?
Right, yeah. So because it's a little bit delayed due to the supply situation at the moment, we had the opportunity to directly integrate the new 2.5 gigabit Ethernet controller from Intel, which we also announced for the additional module. And so the device has now integrated 2 times 2.5 gigabit, and you can also add this module in the future, and then you have up to 4 times 2.5 gigabit Ethernet. That might be a very good opportunity in the future for vision cameras with 2.5 gigabit.
Well, every good PC needs a UPS. I think that's the next topic for new products, and that's right here.
Yeah, as you may have seen already, our existing series of additional UPS modules, which you can use with our PCs or embedded PCs. And the unique thing here is that you can directly connect the UPS with 24 volt. And then we have a OCT technology where we transmit the data over the 24 volts. So you only need one wire, the 24 volts, to connect the UPS to the PC, and everything else is then done automatically. And now we have an additional module, a smaller module, because we have these smaller devices like CX56 or like C6015, which do not require that many power or capacity. And therefore we developed that smaller module with smaller capacity, but it is sufficient for devices with Atom CPUs. And of course it saves space in the switch cabinet, and of course it saves also money.
Well, the system is growing, the modules are growing, but this is a good point to take a quick look into 20 years embedded PCs, because this is how long we are supplying embedded PCs, and that's something we have over here. I started 20 years ago, Heiko.
Yeah.
You started 15 years ago
Right.
with Beckhoff, and I think embedded PCs started around here.
That's right. So 2002, we invented the first embedded PC, which was called CX1000, and this is still the successor already here, the CX1010. And the CX1000 was the first PC from Beckhoff on the DIN rail where you could directly attach the I/O terminals. Before that time, we only had big ADX PCs or very small microcontroller-based bus couplers, we called it. And this was the starting point for the embedded PC series, but also for the own Beckhoff motherboard development, because there was no motherboard at this time on the market which fit into this kind of housing, and therefore we had to start developing our own motherboards.
And now we scale from the smallest one with 400 megahertz CX7000 all the way up to the biggest one. Maybe Malte, you can go up and up and up. And what is the high end, Heiko?
Yeah, so the high end today is a 12-core Xeon CPU on the DIN rail. And starting from the very small one, you can say today we have more or less the broadest portfolio of DIN rail-based controllers in the market.
And there's always something new, but there's also something traditional. And in terms of operating system, that's the same situation. We still rely on Microsoft operating systems, but with TwinCAT BSD, we presented already an addition to the system. What is the quick update on TwinCAT BSD?
Yeah, so TwinCAT BSD was introduced into the market last year, and we already have several customers using it in their serial machines, but today still without HMI, without graphics, so it's headless systems. And now we are planning for the third quarter this year that we also have directly HMI integrated with a full screen browser, like you see here, so that you can also use the HMI directly on the PC. In addition to that, we will also, of course, add new controllers by the end of the year with TwinCAT BSD, but this is a topic for the SPS fair by the end of the year.
All right, so the portfolio is growing, and this is also true for our I/O module system. And let's go quick to Felix, and he talk about the updates in I/O business.
Okay, Roland, as you know, we offer more than 700 different terminals for collecting and sending data within a machine. And I would like to talk about one very special signal with my dear colleague Fabian here right now about measuring analog values, about measuring power. How do we do this with our I/O portfolio?
Well, in the best case, very simple. You take only one, not all these terminals, only one, and put in voltage and current. And if it's less than 5 amps, then you're done. Usually, machines do need more than 5 amps, so probably you also need our STTs, our current transformers, which put in huge currents here and small currents here, and therefore they connect it, and then you can measure whatever you want.
Okay, engineers always want to simplify everything. Can we integrate this and this into something?
This is quite big looking in comparison to each other, right? But yes, more or less we can. Actually, we have our distributed power measurement system, so think about you need more than one measurement point. Usually you have to cable voltage and cable to all these measurement points. Using our distributed power measurement, you only need to cable the currents because the voltages are transferred via EtherCAT, and so these terminals doesn't need that anymore. And this single terminal can measure 6 current channels, and looking on these 4, they are more or less in this last terminal. So here, 4 of those are integrated, so that's I would say, already quite good.
So, okay, a lot of current transformers moving into the bus terminal, but is there actually anything else which we can measure beside current?
Yes, well, current, you probably mean power, because
Exactly.
current is always measured in this current transformers, but the way the current is measured can be different. So this is very simple. Here is a more difficult one, because here we now measure a differential current. So here you have only one cable going through your current transformer. Here we have 4. So that's why we now measure the current which is going in and out of the machine and searching for if something is missing. Because if something is missing, maybe your isolation of the machine is not that good.
Okay. I once took part in an insulation measurement for an office lamp. The office lamp passed, but I guess measuring a packaging machine is much more difficult, right?
Well, that's very correct. Yeah, lamp usually has an off and an on state. A packaging machine has maybe 2 or 3 more of them, and some of them actually do have circumstances where it is okay that the resilient current is flowing through the machine. So you need to know that. And since we are PC-based control, we do know what is actually going on in the machine, and therefore we can distribute how it is okay or when it is not okay that there is this differential current.
Thank you very much, Fabian. A wonderful example for what we can do by combining our knowledge about all the I/O technologies which we have, and we would like to make all of these things available to users of other technologies. So I'm here with Rob now, who can tell us something about the NCT technology as a base technology for XTS.
So the NCT technology is no cable technology. This is wireless data and power transmission to the mover. So basically we take a normal mover and we bolt on the NCT electronics, and that gives us 24 volt power, 35 watts continuous, 75 watts peak. It gives us all of our data communication, and from there we can add pretty much any signal that we have in our portfolio for I/O. We can put it directly on the mover and talk to it and control it.
Perfect. And what can we do with it?
So that's the easy part, right? We take our normal XTS motor module, made it a little bit thicker so that we have the antennas and everything right in the motor module. And one of the things that we can do is we can talk to everything synchronously. So here we have 2 movers working together, working on the same product. And we can make sure that the data coming to the movers happens at exactly the same time. So we've got little vacuum pumps bolted onto the movers, and then we can trigger each one and say, yes, turn the vacuum on and pick it right now. And that then happens synchronously on each mover within a microsecond.
Okay. A perfect example for the combination of motion technology and our I/O portfolio, and I think that's a perfect end for today's technology part. Back to Roland with some last organizatory points.
Well, and here we are back 27 minutes later. We need to hurry up. Your questions will be answered via email or in the chat. Tomorrow we are back here at 10 o'clock with our live stream. But now we have to switch over to a second live stream, unfortunately in German, because the Chancellor is coming any minute, correct?
Yeah. And we will show a comprehension of that on Tuesday. Don't miss out on that.
And these guys are done for today. Thank you for joining. And stay tuned on the German channel. Bye-bye.
Bye-bye.